Hello friends, a very cool good evening to all of you. This is Mukesh Saigal standing in our factory at Vasai. Here we have on display a beautiful equipment on ZLD solutions. ZLD is zero liquid discharge. Now these are the government norms which says any effluent from a chemical plant or a pharmaceutical plant cannot be discharged directly into the waste. First they have to treat it. After treating the water, you come to a situation where the TDS levels are so high that effluent cannot be discharged with that high TDS level. And there is no further process which can be done on that liquid. That is where the multi-effect evaporator comes in. Industry presently is using multi-effect evaporator. You can have 3-stage, 4-stage, depends on the designs what are followed. In multi-effect evaporators, you have 3-stage evaporators, you have got 4-stage evaporators. Now, whether it is a 3-stage or a 4-stage evaporator, still consumes a lot of energy because steam doesn't come free, steam consumes a lot of utility. In our case, what we did, we created a system wherein this wonderful machine what you see here, it is a hot water generator. It generates hot water and gives us chill water also. This chill water you can use it in your process cooling. This is going to be free of cost. And the waste condenser heat that is used to generate hot water, this hot water can be till about 55 degrees centigrade or even a 60 degrees centigrade water. What you see here, this is a sludge tank or an evaporator, you can call it as an evaporator. What you see on top is the sludge motor, which is rotating the sludge so that there is effective heat transfer between the hot water jacket and the inner liquid. What you see here in this particular section, this is nothing but a hot water jacket. This is the sludge tank, and this hot water which is generated free of cost from this wonderful machine is circulated all around. Now when this is circulating, it is heating up the inner liquid. Now the inner liquid or a sludge, high TDS effluent, that also gets heated to about 55-60 degrees centigrade. What you see, this black pipe, this is nothing but a vacuum line. So what we have done is we have created a vacuum. If you see this gauge, this is a vacuum gauge. So what we are doing is we are creating a vacuum in the sludge tank or the evaporator. The moment we create a vacuum, the boiling point of the water goes down and water starts boiling at about 55-60 degrees centigrade ferociously. This vapors what are generated, that is sucked by the vacuum pump, and then it is discharged through the vacuum pump. It is discharged into the collection tank. There is a collection tank behind, and so what we have done is, in this beautiful arrangement, whatever chill water is generated and whatever hot water is generated, this we have got tanks here. There is a hot water tank, there is a chill water tank. In the hot water tank, we have got primary circuit pumps, secondary circuit pumps, and on the chiller side, we have primary chill water pump, secondary chill water pump. So this is nothing but a plant room which has got tanks, which has got pumps, and so this is having all the basic configuration of the machine which is transporting chill water and hot water. Hot water runs into the jacket, it heats up the effluent. Then what you see here is a vacuum pump. So this is creating a vacuum. Then what you see, there is a heat exchanger there. then there is a collection tank. So all these 4 equipments are integrated together and it gives you multi-effect evaporator. Now comes the main punch. If you take 100 kg of water and it has to be evaporated in 1 hour, if you take a 3-stage multi-effect evaporator, it consumes almost about 22.5 kW of power is required. For 100 kgs per hour steam evaporation, what we need is 22.5 kW of power consumption. When we use this system, only 2.2 kW of vacuum pump is required. That's it. Chilled water you are using in your process, so that gets consumed there. Condenser heat or the hot water is absolutely free of cost. So whatever heating is done in this evaporator is absolutely free of cost. No steaming cost, no electric steaming cost, absolutely free of cost, So against 22.5 kW of steam kilowatt consumption, we are using only 2.5 kilowatt of power. So you get about 95% of power saving. This means we are able to save almost about 20 kW of power just for 100 kgs per hour evaporation rate. With this machine, this evaporator which you are seeing is capable, and this whole arrangement is capable of evaporating 500 kgs of water in 24 hours. That's the capacity of this system, 500 kgs for 24 hours. And whatever power saving which I just talked to you, 95% power saving. That is, we have taken a typical example or a case where 100 kgs per hour of water when evaporated. So whether it is 100 kgs or 1000 kg or maybe a 1 lakh kgs per hour of evaporation, your power saving is going to be 95%. So this is a wonderful system, wonderful concept which can be used in our day-to-day engineering, and we have created a demo model here.